Hello and welcome to physics, and in this short tutorial video we are going to discuss about free fall. Going straight into it, we are going to do the following. The first thing that we are going to do is to describe acceleration due to gravity, and the second part is we are going to describe quantitatively for an object falling in uniform gravitational field with or without air resistance. With me here is an object showing falling through the air. Now there are two forces of attraction that acts on an object that is falling through the air. The first one is the force of gravity, the other one is air resistance. Okay, so the force of gravity is a force that is exerted on an object and causes an object to fall down through the air, and it acts in this direction downwards. And another force of that acts on an object as it falls is the air resistance. Okay, so air resistance is yet another force that acts on an object as it falls through the air, and it acts upwards, opposite to the force of gravity. So mainly these are the two forces of attraction that acts on an object. Now, free fall is when an object falls through the air and the only force that acts on it is the force of gravity. So what we are going to do is we are going to rub out our air resistance like that, and in most questions we say ignoring this force and only allowing only one force to act on an object. So if we have the only force being the force of gravity acting on the object as it falls, and we ignore air resistance in that scenario, then we say an object is falling freely. It is falling under free fall. So free fall, it is just an object falling through the air and the only force acting on it is the force of gravity. So that's what free fall mainly is. So after discussing what free fall is, we are now going to qualitatively discuss how we can calculate different parts of the motion of an object as it falls through the air. As an object is falling through the air and the force of gravity acting on it is the acceleration due to gravity, then it is going to fall at an acceleration which is equal to approximately 10 meters per second squared. 10 meters per second squared. That means that every single second it falls at a speed of 10 meters per second. So in 2 seconds the speed increases to 20 meters per second. So in 3 seconds as it falls, the speed will increase to 30 meters per second. So as an object is falling, its velocity increases as it falls through the air. Now there are two important scenarios that we need to understand as an object is falling through the air. The first one is when an object is thrown in the air opposite to gravity. So what we have here is throwing an object in an upward motion or direction, vertical, projecting it upwards like that. So the main things that we need to know is that when an object is thrown upwards, there will be a point where an object will stop momentarily and then it will start coming down. So we say that an object has reached a terminal velocity there. By terminal velocity, it's just the maximum constant velocity an object reaches as it falls through the air. So the final velocity, the terminal velocity for an object thrown upwards is actually 0 meters per second, because it stops momentarily, so its speed reduces. That's why it stops. So an object thrown upwards, the speed reduces to a final, which is 0 meters per second. But the acceleration due to gravity it experiences is actually negative 10 meters per second squared. Negative 10 meters per second squared. So this is the gravity that an object will experience as it falls through. But the initial velocity for this object is never known, because we don't know how much we have allowed to throw this object upwards. So this is one motion that we need to know. An object thrown upwards, its gravity is negative 10 meters per second, and its final velocity is 0 meters per second. Its initial velocity is actually never known unless we are given in the question, we calculate for it. The other projection is when an object is allowed to fall from a particular height, or released to fall. So when an object is released to fall from a particular height, its initial velocity is actually 0 meters per second, because it falls from rest. And then it experiences gravity, which is in this case positive meters per second, approximately positive 10 meters per second squared. And its final velocity is never known unless we calculate for it, or unless we are given in the question. So there are two main important situations that we should look out for when we are given a question. The first one is where an object is thrown upwards, its final velocity will be 0, gravity will be negative 10 meters per second squared. And the other one where an object is released to fall from a particular height, and its initial velocity is 0 meters per second, gravity is positive 10 meters per second squared. And then the final velocity is actually never known. So let us see with practical questions to prove how we can calculate for different physical quantities as an object falls through the ground, through the air. Okay, so here we have an example where we are going to show how we can calculate for different physical quantities and if an object is thrown through the air as it goes through the air. So first of all, we'll concentrate on vertical motions. By that we mean an object falling through the air, of course. Now, when we have an object that is thrown upwards through the air, like in this example, we have a baseball which is thrown vertically upwards with a velocity of 20 meters per second. Then we can conclude from what we have discussed already that in this case an object is thrown upwards. We are going to draw that here. What we said is that if an object is thrown upwards, always the acceleration due to gravity is negative 10 meters per second squared. And the final velocity for that object will always be 0 meters per second. So these are the two important variables that we should know if an object is thrown upwards, like in this case. Now we can also add up to these variables because we've been told that this baseball was thrown with this velocity, which is 20 meters per second, meaning the initial velocity when it was thrown, at which it was thrown at, is given. It is 20 meters per second. So we have three variables that we can have to help us calculate the questions that we are given. Now, we have been given the first question. It says, let's find the maximum height reached by this object as it is thrown from this velocity, and it experiences this gravity, and as well as the final velocity there. So in order for us to calculate the height, we have linear motion equations that we discussed in our previous lessons, that for those linear motion equations, 4 of them in total, can help us to calculate such questions that we have, since we know that the acceleration is uniform. Therefore, we need to find an equation that has final velocity, gravity, and initial velocity with height in it, in order to find for height. So if we go through one of the important equations that makes up those linear motion equation, is where we said that S is equals to ut plus half at squared. So where the S in this equation, we are talking about distance. So because this is motion, then the S becomes the height. Then the A is the acceleration, because this is vertical motion. The A ceases to be acceleration, becomes acceleration due to gravity. So that's one of the equations. So when do we use this equation? We use this equation if we want to find the height given the initial velocity, the time, and the acceleration due to gravity. If you can compare our variables there, we have the initial velocity, which is 20. We don't have the time, so we cannot use this equation because there are 2 variables that are missing, unless if we had time, we could have used that equation. Then we have another one which says V is equals to U plus AT. In this equation, we want to find final velocity if we have initial velocity, acceleration, and time. Yet again, we do not have time, so we cannot use this equation to solve for it. The other equations will be V squared will equal to U squared plus 2AS. In this equation, you're finding final velocity if you have initial velocity and you have acceleration and there is height. If we check in our example, we have final velocity, which is 0. Then there is initial velocity, which is 20 meters per second. Then there is acceleration also, which is acceleration due to gravity, -10. And the S is the distance, in this case, which is h. It's what we want. So we can see that in this equation there's one variable that is missing, and it is distance, which is height, and it's the one that we've been asked to find. So this is the equation that we use. So in short, we are saying you find an equation that has all the variables stated in the equation. So we are using this equation to solve for S. By this, we can either make S the subject of formula, or we just substitute in our variables. So I'd rather make S the subject of formula. So V squared, the U squared, cross the equal sign, become -U squared. And then what will remain this side is 2AS. Then we divide both sides by that which is attached to what we want to make the subject of formula for, which is S. So we divide by 2A by 2A. Then we can say S, which is the same as saying maximum height, is the same as V squared minus U squared over 2a. The v squared is the final velocity. So where there is v, it is final velocity. So v is 0 squared. The u is where there is initial, which is going to give us 20 squared. Then we have 2 multiplied with the a. A is the acceleration due to gravity, which is going to give us negative 10, like that. So once we have this arrangement, we can do arithmetic here and say negative 20 squared is the same as saying 20 times 20, which is going to give us 400. Mind you, it's a negative because this is 0 squared minus 20 squared, which is negative 20, like that. And then 2 times negative 10, that will give us negative 20. Therefore, 2 into 40, that will give us positive 2, 0. And since this is height, so this is the maximum height reached by this object as it was thrown upwards. So the total height covered from this point up to the total vertical height, it's through the final velocity, it's 20 meters. So that's how we can solve for this one. We can go down to this one and try to solve for it. Here we want to find the time taken to reach this distance. So in order for us to find an equation, again we need to find the equation which has all the variables. So if I was to check for this equation here, I have my final velocity, which is 0. I have initial velocity, which is 20. I have the acceleration due to gravity, which is negative 10. Then I can find for t, the one that I've been asked. Therefore, straight up, I will use v is equals to u plus a t. So in this equation, we just substitute to find t, or we make t the subject of formula. So we'll do the latter. V, u is positive, crosses, becomes negative u. Then we remain with 80. Divide both sides by a, so that our time is the same as saying v minus u over a. If we substitute in, we'll have final velocity is 0. Our initial velocity is 20. Our a is acceleration due to gravity, which is negative 10. Therefore, our time is the same as saying this is going to give us 1 into 10 into 20, which is the same as saying 2. And the negative and negative cancel out, so time will give us 2 seconds. So we can conclude here that the time taken for this object, this baseball, to reach this height of 20 meters was 2 seconds. Okay, so we have our second example. In this case, we want to see what is happening in the question again. Looking at in our first example, we discovered that the object was thrown upwards. So in this example, it says an object is dropped from a height which is 80 meters. So here the keyword is dropped from a height, meaning that in this example we are dealing with downwards motion, which is the opposite motion that we discussed in example number 1. So here we understand that the object is dropped down from here and before reaching the ground there. What we have been told is that this object covers a height of 80 meters, meaning the total height covered by this object is 80 meters. Now, like we discussed in the beginning of the video, that if an object is released to fall from a particular height, then it starts to fall with an initial velocity which is 0 meters per second. Okay, so the initial velocity for this object as it falls through this height is 0 meters per second, and because it is falling downwards, in which acceleration due to gravity is also acting downwards, then it is experiencing a gravity which is positive 10 meters per second squared. So the acceleration due to gravity experienced by this object is positive 10 meters per second, and the height that's fallen, it is 80 meters, and the initial velocity to which it's been dropped with, it's from free fall, so it's been released, so it falls with this value of 0 meters per second. So now what we are asked in the question is time taken, and thereafter the velocity just before hitting the ground. So here we want to find the time it takes for this object to fall this height. So like we said, you need to find an equation that has all these variables. So if we are to investigate all these equations, we'll just go to one which I feel has all these variables. And if I look at the first equation, it says for me to calculate height, which is distance, I will need to have initial, which I have, it's 0. I need to have time, which I do not have, but it's been what I've been asked to find, and I need to have acceleration, which I have, and time, which I don't have. Therefore, this is an equation to use because we have h, substituting with s, which is the same as saying distance, will equal to ut plus half at squared. Why this equation? Because all the variables in these equations are given unless the one which you want to calculate for, and that's how you find your equation. So your h is the 80 meters for this object as it falls. So this is 80 will give us u, it's 0 meters per second, we multiply it with the time which we are looking for, and then we say add half multiplied with the acceleration due to gravity, which is positive in this case, so it's positive 10 times t squared. Okay, so we have substituted. Now we do our arithmetic, and then we'll say 80 will equal to 0 times t, which is 0. Then we'll say 2 into 10, that's 5. So it's the same as saying 1 times 5 times t squared, which will give us 5t squared. And then at this point we collect like terms, which is the same as saying 80 is equals to positive 5t squared. Then divide both sides by 5 by 5. So our t squared will equal to 5 into 80, and this will give us 16. Now this means that the time is squared, meaning that I need to find the number when multiplied by itself to give me 16, and that will give me a 4. So 4 times 4 will give us 16, meaning that the time taken to cover this height, 80 meters, was actually 4 seconds. So that's how we calculate for time taken, like that. You find an equation that has all the variables, then substitute, and then you have your answer in no time. We go to B and we solve for the last one. In this case, we want to find the velocity before hitting the ground. So just before the object touches the ground, what was its velocity? So we can do this in two ways. The fact that we said that if an object is falling through the air and the acceleration due to gravity is the only force acting on it, and we ignore air resistance like in this case, then every second it will fall with the speed of 10 meters per second. So we are going to pause on that one and then use the other way of actually employing a formula to solve for this question. So in this case we find an equation again where we have all the variables plus the variable that we want to solve for. So if we check on our linear motion equations, we have, I think the second equation best suits this question. The final velocity will equal to initial velocity plus at. In here we want to solve for v. So we have initial, which is 0, we have acceleration, which is positive 10, and then we have time, which we have found, which is 4. So we just substitute. So our initial velocity is 0, our acceleration is positive 10, and our time is 4. Therefore this will give us 40 meters per second, meaning that in this case the velocity just before touching the ground for this object was actually 40 meters per second. And this can also testify to the fact that if the total time taken was 4 seconds, meaning that we just multiply this 4 times the acceleration due to gravity every second. So this will give us 40 meters per second. And this is how we can find the final velocity given the variables. The most important thing that you need to know is, first of all, identify what kind of motion it is. Was an object thrown upwards, or was it released to fall through the air from a particular height? Then the second part is, given a question, collect the information and compare with the variables that you have in the question. Hopefully you are able to acquaint yourself with acceleration due to gravity. See you in the next videos.